It's time for another math easy solution. Here to discuss more trigonometry and look at basic examples on finding the period of trigonometric functions. Do part one of this series to go over these two examples here. Basically, in my earlier video I showed how to graph trig functions and etc., showing how to transform and translate them, etc. But then I didn't go into the period, finding the period because of the functions here. It's a bit complex here. We'll go over these examples. I'll go part one a bit slowly just to go over how to find period just more in depth. So we'll start off with this first example. And the first example is basically this one. I rewrote it down here. Y is equal to 2 cos x plus sine 2x. I'll just and also note I'm going to do these next two harder ones in another video. So stay tuned for that. So now let's look at this one here. So what I mean by finding the period, if we just look at, let's just look at this function alone. Yes, if we just look at, well, even excluding this 2 here, so we have this cos x here. As you can see, this with trigonometric functions, it just goes up and down, and it repeats with having a period, or basically where it repeats. And this one is going to be 2 pi right here. This is going to be a value of pi, so that at this point is 2 pi, and it's going to repeat every single 2 pi here. So that if you go next 2 pi, it'll be the exact same thing. If you add this 2, I showed in my earlier video, all this does is just vertically shift it up, or just extends it here, so makes it up here. So yeah, I just here I graphed 2 cos x. So as you can see, this one the period stays the same here. So we'll just call p is equal to 2 pi as well. So it doesn't change. All you're doing is just multiplying whatever this value is. You're not actually changing the x translation or shifting or any way. And this value is going to be 2. So all you're doing is multiplying by 2. So when we're looking for the period, we could just ignore all of these multiplications that are outside. But these, all we have to do is look into these inside ones. Okay, so now what we have to do is look at now the second part, because we know that the first part has a period of 2 pi. So what's this second part, sine 2x? What's the period? Okay, so now before we get to finding the period of sine 2x, let's look at the graph of sine of x here. So as you can see here, you've probably seen this many times. It just looks like something like this and repeats, has the same period as cos of x, and it's going to be just 2 pi here. So it repeats every time here. So now the idea of this 2 here, how does it affect the period? Well, let's look at when this value is, when the sine has this value. So for what I mean by this is when you have sine of this value of 2 pi here. And then from this one, you can find the period like this. And you know that the y value is going to be 0 right here. So basically when you have this, I'll just put in this bracket, this equals 0. So now this one right here, yeah, for the function that's this graph right here, sine of x, this is just when x is equal to 2 pi here. So now all we have to do is find the equivalent. Yeah, all we have to do is find the equivalent x value here to get sine 2 pi for this function here, sine 2x. And to do that, all we do is just equate them. So we're just going to have sine 2x is equal to sine 2 pi. And this is only true if these are equal. The insides, so you're just going to have 2x is equal to 2 pi. Cancel the 2's, you're going to have x equals to pi here. So what this means is for the other function here at x is equal to pi, you're going to get sine of 2 pi for the function sine 2x. So now we can just graph it. All you're doing is actually shrinking it, and this one is in fact the period. Yeah, period for this function right here. Now in fact a good way of showing this is if I just graph or just draw over this sine of x with this value right here. And so all we're doing now, the new equivalent to pi is going to be at pi if this is the function 2x. All we do is just shift it in here, or just compress it. So this is the new function. Yeah, this is sine 2x here, and as you can see right here, this is pi over 2, and it's equivalent of pi here, or this divided by 2 factor here. So all we're doing is dividing by 2 in every single spot. So this is the period for this one here, which is called p is equal to pi. Okay, so now let's recap what I've just gone through here. Basically, we have the period for both of these functions here. The 2 cos x is going to be 2 pi. For sine 2x is going to be pi right here. So, but when we look at the combination of these right here, so we have to find out what this period is. If we just graph these out just to get a visualization of what we need to look for when we're looking for the period. But basically look at this one here. This is the 2 cos x is the blue. The red is going to be the sine 2x, and then the orange is the combination of the two. And as you can see, this period here, yeah, this function here repeats itself basically when there's a multiple of, like when both of these ones start repeating themselves at the exact same time. So what I mean by this, if you look at this graph right here, this one's going down like this. and this one's going up like this. And then when we look at the period here, because as you see, every single top here, it's repeating. And this is roughly, if we look at from here to wherever it looks like, let's call this intersection right here. This is in fact 2 pi here. This period is 2 pi. As you see, it's repeating it every single time here. So roughly even this spot right here goes to, because 2 pi is around 6 point something here, 6 points, I'm not sure. But anyways, as you can see that the period's 2 pi. But just to get an idea without graphing what's happening here, as you can see, this blue one, the 2 cos x, it has a period of 2 pi, so it's going up. And then at this point it starts repeating itself. So this period is 2 pi. And then this one here, it's repeating itself twice here. So this is the sine 2x. So it goes up, that's 1, and goes back down. So that's 2 right there. Yeah, thus basically the 2 cos x sine x has a period in which both of these two functions here start repeating, or is a multiple of both periods here. So what I mean by that is, what I mean by this is, if you have one period is 2 pi, the second period is just going to be pi, then basically a multiple of this would be just 2 pi here. Just as a whole integer multiple here, we're going to have this one goes in there once, and this pi goes in here twice here. So I mean, this goes into it once, this goes in twice here. As you can see, yeah, this is what it should be. So this is the period of for this function here. As you can see, that is the period. It's moving like that. And now I'll just do the second example pretty quickly just to illustrate this. Even if it's multiplication, it's gonna be the same thing. So now if we look at the second example, instead of addition, we have multiplication. And in this case, again, we know that this period is gonna be, call this P1 is equal to 2 pi from above. And this one here, this is the 2x here. This is going to be a period we'll call P2 is equal to pi here. So the multiplication here, all this is meaning now, if we look at the exact same method here, is when both of the stuff start repeating each other. Because all this means, the multiplication of these two, is that you're going to be multiplying, well, different ratios at different times. But then since they're always going up and down, you're going to have a repetition period. And in this case, it's the exact same thing as the addition one. So this period of, we'll call it P1 times 2, this one's also going to be 2 pi, and you could even graph it pretty easily. So yeah, if you graph it with Google here, I just have it like this right here, just to show you. This is this 2 cos x sine x. As you can see, because the periods in both of them is going to be, this one's going to be 2 pi, this is pi, it goes up like this. And then it should be 2 pi right here, so, and that's where it starts repeating itself. So every 2 pi from this where my mouse is all the way to this 6.2 whatever, I'm not sure what that is, 288 or something. Yeah, because 3.14 is pi, so yeah, 3.14 ish, and then so 6.28, that's the period here. So as you can see, it starts repeating every single 2 pi. If you were to graph the other ones to it, so yeah, if I graph the 2 cos x and sine x, the red is 2 cos x. As you can see, this period is 2 pi. This one is going to be pi. So this repeats twice until they both start repeating at the same time, and that's at this 2 pi. Yeah, and I just copied and pasted that same graph here just to show you this is the period 2 pi here. P1 times 2 is equal to 2 pi right here. So yeah, well, that's all for today. Hope you learned about these examples on how to find the period of trig functions. It's useful when you start graphing it, because all you have to do is just look at those two, and then just look at the period as the interval, and then basically repeat that curve once you find what it is. And that's all for today. I'll do another video on more complex complex period trigonometric functions here, and solving period for these two in another video. That's all for today. Remember to download these notes in the Dropbox link below, and stay tuned for another math easy solution.